as I said, for the derivation of the law of cosines, the use of triangles are used like extensively in engineering. So in this video, I'm going to show you the proof or the derivation of the law of sines, a very useful formula or theorem. So what we're going to do, we're going to start off with this basic triangle. What we know are two sides of two sides, or all three sides, and the three different angles. But theoretically, all you need is two sides and one angle, or one side and two angles, or you'll see what we'll need. But these are technically unknown, and we want to find the relationship between the sides and the angles. So what we're going to do, we're going to start off by drawing a line right here, which is perpendicular to that and perpendicular to that. So what we can do, we could define this component, since this is a right triangle, by using some trick. That's a sine theta. And then this is an angle, so it'll be c sine of alpha. So already, since this is the same vertical length or distance, we could equate these two values. So we could say that a sine theta is equal to c sine theta, or c sine alpha, sorry about that. And then what we're going to do, we're going to separate these so they're more of a proportional equation, if that makes sense. So we're going to say sine of theta over c equals sine of alpha over a. So we're almost there. This is half the journey. So what we're going to do, I'm going to try, at least I don't know if I'm going to do so well, but technically it doesn't really matter. So just imagine this is the same exact triangle. And what we're going to do is that I'm going to define another straight line. It's going to be very difficult, but oops. Nope. Okay, so what's going to happen? Just pretend this is a right angle. It's going to be very difficult to see. So, and this angle right here is phi or psi. And then this is going to be theta. This is going to be b, and this is going to be c. So as we did before, we could define this length right here as b sine of theta, and we could define this length over here as c sine of phi. So what we're going to do, as we did before, since this is the same length and same line, we could equate those two things. So b sine of theta equals c sine of phi. So as we did before, we're going to make them into quotients. So it'll be sine theta over c equals sine phi over b. And what we notice is that this right here is equal to this right here. So now we have the final equation. So what we can write is that sine alpha over a, the length of a, is equal to sine theta over c, which equals sine phi over b by this equation. So this is the law of sines, which is very useful when you have to find angles or sides. It's a very simple equation. It could also be written as this by just simply flipping the orientation. It can also be written like this if you prefer it. It doesn't matter. And there you go. That is the derivation of the law of sines. It's very simple. All you have to do is draw a line that is perpendicular to this line from this angle. You can find the relationship between the sides and the angle. And then you repeat the process from a different angle to the other side, and you get the same derivation. And then you equate these two formulas that we found right here, and then we get the law of sines. So that is a very simple, short derivation of the law of sines.